Hello, everybody. Today we are going to talk about application problems that we can use the quadratic formula to solve. So first off, I'm going to talk about two formulas that we're going to be using. The first formula is negative 16 t squared plus or minus v naught times t plus s. And the second equation is the same thing as the first, only the units are in meters per second and not feet per second. So the only difference is the first one has the negative 16, and that's in feet, and the second one has a negative 4.9, so that is in meters. The H stands for the ending height, the T is for time, the V is for the initial velocity, and the S is for starting height. So depending on the information that these problems give us, we're going to plug in what we know and use the quadratic formula, or if it would be easier to use factoring or completing the square. I think using the quadratic formula is going to be the easiest since we have this coefficient in front of the t squared term. It'd be harder to factor or use the completing the square method. But those could also get you the same answer. So this first example says a ball is thrown upward from a height of 15 feet with an initial velocity of 5 feet per second. Use the formula h equals negative 16t squared plus vt plus s to find how long it would take for the ball to hit the ground. Okay, so the first thing I'm going to do is label the information that I'm given. So we get the ball is thrown upward from a height of 15 feet. So that would be the starting height. So S is going to be 15 feet. And it also gives us the initial velocity of 5 feet per second. So we've got V is 5 feet per second. And we're going to use this formula to find how long it will take for the ball to hit the ground. So our t is what we're solving for. So we don't know t yet. Okay, so first thing we're going to do is plug in our numbers. So we have, oh, and one thing I need to mention, the final, in this problem, the final height is going to be 0. So h is going to be 0 since the ball is going to end up on the ground. So our ground is 0 and the ball is thrown 15 feet above the ground. So we're going to have 0 equals negative 16. We don't know t, so we're keeping that t squared plus, oh, whoops, I forgot to write the number over here. This is supposed to be 5. Um, 5 times t plus 15. Okay, so now this equation just looks like the equations that we've been working with. Uh, so they're quadratics, and we are going to use the quadratic formula to solve for t, which is what we need. We need time. So I'm going to label my A, B, and C. A is negative 16, B is 5, and C is 15. So we're going to plug these numbers. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, so when we simplify what's under the radical, we get x equals negative 5 plus the square root of 985 and x equals negative 5 minus the square root of 985 all over negative 32. Over here too, negative 32. Okay, so when we solve these, x equals a negative 0.82 and x equals 1.14. Now we're going to throw out this one because we can't have a negative time. So we're not going to use that one. We are going to use this one. So this would be our t. So t equals 1.14 seconds is our units. And that is it. So it's not too bad. We're still using the quadratic formula, finding our roots, only in this case we're finding our time. And this, if I would draw a picture to show you what's going on here, if we have a person standing, let's say, on top of a cliff. Okay, so we're going to stand up here, and here's the ground down here. Okay, so the person is 15 feet above the ground when he or she throws the ball. So the ball is in this person's hand, and it's going to go up and come back down and hit the ground and end up on the ground. And it told us that our initial velocity was 5. So see here we have a parabola, just like we've been graphing. And we're finding our roots because here this would be like the x-axis. The ground is like the x-axis on our graph, which is what we would use the quadratic formula to find our roots, and we use the quadratic formula to find our time. Okay, let's do one more. So this one says a ship drops anchor in a harbor. The anchor is 49 feet above the surface of the water when it is released. The starting velocity is 0. Use the vertical motion formula, which is the same thing, to find how many seconds it will take for the anchor to hit the water. So first we're going to label what we have. So we have our starting height is 49 feet. They give us our starting velocity is 0. And that is it. And we're solving for time. Oh, and our height is 0. Okay, so we're going to plug in our numbers we know. So we know 0 equals negative 16 t squared plus 0 times t plus 49. So this 0t just goes away. So we are left with 0 equals negative 16 t squared plus 49. Okay, so I'm still going to use the quadratic equation, that negative 16 in the A position kind of messes things up, makes it ugly. So use the quadratic formula. So A is going to be negative 16. B is 0 because there's no coefficient in front of the t term. And C is 49. So we're going to plug in these numbers. X equals negative b, which is 0, plus or minus the square root of b squared minus 4ac all over 2a. Okay, so we're going to split this up into x equals plus the square root of 3,136 over negative 32, and x minus the square root of 3,136 over negative 32. When we solve these, x equals negative 1.75, which we know can't have a negative time, and x equals 1.75, which is our answer. So the time it takes for the anchor to hit the ground from the boat is 1.75 seconds. This picture would look something like, here's the boat. Doesn't look much like a ship, but okay, bear with my anchor. Okay, something like that. And our water is here. And the distance from where the anchor is to where the water is 49. So the anchor is dropped, and the time it takes to hit the water is what we find. All right, that's all I have for you today, and I will see you in class.